Okay, let us start. Let us start. Let me see where should I start here? I will share the screen first. Can you see my screen?
Yeah.
Okay. Can everyone understand English and Chinese just to make sure? So I can use both language when needed.
Yeah.
Okay. That's a big yes. All right. So I'll assume everyone knows Chinese and English. So from time to time, I'll switch between languages, but mainly we will use English. Right. So let's start. Yeah. First of all, let me say this. I know some of you are here because you choose to be here. And some of you are here because your parents made you come. Right. Either way, you are here now. And since you are already here, sitting in this room by yourself, why not just make these 2 to 3 hours the best investment of your time? Right. So here's my request. Open your mind. Don't block yourself with this boring or this won't work for me, right? This type of mindset. Just give yourself permission to try. I want you to at least try for these 2 to 3 hours. Since you are here, just open up your mind for these 2 to 3 hours. Because I promise you, by the end of this session, you will walk away with something that can change the way you think about studying forever. And let me tell you the big problem most students face. Maybe this sounds familiar. You spend hours and hours and hours of reading, but when exam result come back to you, right? When you get your exam result, the grades doesn't match the effort. Does it sound familiar? Can I have some response? Does it sound familiar?
Yes. Yeah.
Okay, that's good. And that's the problem number one. There are two problems here. Let's focus on the problem number one. And what is the problem number one? There is no clear method. And some of you already discover some of the, I mean, I'm sure there are bright students, and some of you here are, I'm sure you are really bright student. And some of you already discover the right method without realizing it or realizing it. If you are that type of student, then you're fine. But many of you are still stuck with this endless cycle, reading more and more and more, but not getting a better results. And what is the problem? It's going to demotivate you to study further or to put more effort in studying or in learning. So this method, I hope, is going to help you to solve this problem. And that is problem number one. Problem number two, I name it flying brain problem. Okay, this is the number 4. Later, I'll go through 1 to 4 again. Okay, but just focus on the problem that. Let me see who is here. Okay, someone is here. Right, Venice is back. Okay, problem number 4, the flying brain problem. And I think you know what I mean. Let's imagine yourself started reading page 1. And then page 1, you have the top part, you have the middle part, and you have the end part before you flip to page 2. When you started to read this page, you'll be focusing on the first part, the upper part. And then you start to continue to read to the second part, the middle part of the page. And then your eyes will be reading the third part, the last part of it. Before you know it, you already finish the entire page. But before you flip to the second page, sometimes you might ask yourself, wait, what did I read just now? You think that you were reading, but in fact you were not reading. Do you have encounter this problem before? Can I have a response a bit?
Yeah.
Yeah. And this is what I call the flying brain problem. right? Your brain flew away. Maybe it was thinking about WhatsApp messages that I need to reply. Maybe it's thinking about the football or the badminton activity that I need to play. Or maybe it's talking about what's for lunch later, right? And now, even though you spend the 2 hours, the knowledge did not stick. And that's why learning often feels boring and painful. You put in time, you put the time in and the hours of reading, but you do not get the rewards. And hope that with this method today, we are going to change that, right? And I'm here to introduce this study method called BrainDrawer study method. There are 4 main principles that you need to know before we can dive into use this BrainDrawer method to teach you quantum physics. And let's see how successful we are going to be in the next 2 to 3 hours. Right. Are you ready?
Yes, yes, yes.
Can I have some reaction? Yes, yes.
Okay.
Right. So there are 4 principles. The first principle, student A versus student B. Let me show you the presentation. Right. There's a wake up moment. What if being smart isn't about talent, but it's about using the right method? And what is the difference between student A and student B? Let's imagine that student B is what you are right now, the current self of yourself, the version that you have right now. And student A is the version that you want to be upgraded to a smarter student, right? So can I have some response? What do you think a smart student has that a not so smart student doesn't?
Good attention span.
Attention span? Yes, there's one. Let's get one more. Anyone want to try? Okay, it's okay. I will critical thinking skill. All right. So there are actually 3 skills. There are 3 skills, 3 trainable skills. I call them wait, let me pull it up again. Right. 3 trainable skills, the knowledge base, the speed of recall, and how well you store your new information systematically in an organized way. Right. So the number 1, imagine Elise A and Elise B. Why Elise A is smarter than Elise B? Because Elise A obviously having a bigger knowledge base. She knows more than Elise B. So this is a skill that Elise A has that Elise B maybe not yet having this skill. The second skill is Elise A is able to recall the information inside this knowledge base faster than Elise B. What do I mean by that? I'll give you one example. Today, if you have to answer a question in the exam, you need to be able to recall the information that you store in your mind or in your brain fast enough to answer the questions. So the speed of recalling this information, a skill that you can train. Number 3, store information systematically. Elise A and Elise B, what is the difference? Elise A, when she identify new informations or new knowledge, whether it's through watching a YouTube or whether it's through talking to somebody else who is smarter than her in certain topics, and she is able to identify that particular knowledge or information which is new to her, and store it inside the knowledge base that she has been maintaining for the in her brain, and not only store it in just for the sake of storing. You know exactly which slot to store. You know exactly where to store these informations. Right. So these are the 3 main skills that you need to train, and the BrainDrawer method is going to help you to train this skill to become the smarter version of yourself, which is to become the student A, to become the Jovin A, to become the Jessica A, to become the Shian A, and to become the Elise A. Right. So let's break down in table format. You have the knowledge base. Learner A, which is the student A, she knows more than student B. Recall speed, she is able to recall the information faster than the other student B. And student B is slower, and sometimes it gets stuck. Skill number 3 is the storage. You're able to identify information and store it systematically in a very organized way. Organized way for the student A compared to messy and random for student B. So let's do a metaphor. Let's imagine your brain is like a bookshelf. It's like a big giant bookshelf or big giant drawer. Smarter students have more books inside this drawer. And they know, the smarter student, they know exactly which book and where is it. And they are able to retrieve this book fast when they need the knowledge or the informations. And when there is a new book comes in, they put in the right place systematically. They just don't put in a slot that is empty and just slot it there. They know where to put. The geography book will be organized in the geography section. The science, the physics, the maths, the history, and so on. Right. So one quote I want you to remember: you can be smart with the right method. And this is the method I'm trying to teach you. And let's hope that this method works for you, because this method works for me. And let's see. I've been doing this, is not the first time I'm doing this this session. I think this easily would be the 10th time. Most of the students who go through this method with me, and we took one of the topics, for this case, today we'll be taking quantum physics, he or she understood it pretty well. And it only takes 2 hours, 2 hours to read and to understand a chapter that is as hard as quantum physics. Let me ask you a question. Usually, if you need to read a chapter in one of the subjects, how long do you need to be able to get a good understanding about that chapter? 需要多久时间去读，从第一秒一直到你觉得你很清楚、很明白那个chapter? Anyone? 3 to 5 hours. Anyone else?
2 hours.
2 hours. Okay. 2 hours is very fast. Okay, that's good. If you can do it in 2 hours, then maybe BrainDrawer method doesn't help you, because you already have your own BrainDrawer method to achieve that. Hello, Jahani. Hey, Janani.
Hi.
Hi. Okay. Janani, you understand English and Chinese or just English?
English only, sir.
English only. Okay, good. So we'll focus on English. Yeah, Janani, you came in. So I'll just continue. If you do not understand, let me know. We can explain to you later. So we will not stop the flow of the class. Right. So that is principle number 1. The principle of BrainDrawer study method. How to become student A. Principle number 2 is information plus emotion equivalent to long-term memory. Right. this is the part where I will play a very short memory game with you. I think I've done that with Elise, Jovin, and Shen. Xian, Venice, and Janani. Maybe you haven't done this yet. So let's do it for the sake of the benefit of the tree. We will play this game quickly. Then we can move on so that you can understand what is this about. Right? Elise and Jovin and Shen, are you okay with that? You can take it as a revision.
Okay.
All right. So there's a game that is going to take about maybe 10 minutes. And this game, after you play this game, I call it the memory game, you'll be able to improve your memory by minimum 2 times, double. Is that something interesting, Xian, that you want to try?
Yes, can.
Okay. Now, let me give you 10 items. And I want you to be able to tell me this 10 items in sequence later. Right. Don't write it down. Just listen. I'll start now. Number 1, avocado. Number 2, blueberry. Number 3, broccoli. Number 4, coconut milk. Number 5, eggs. 6, salmon. 7, green vegetable. 8, curry powder. 9, peanut. 10, dark chocolate. Right. Before I test you, let me tell you how the brain works. Or let's start with how you, the method that you use to memorize these 10 items usually. Xian, can you tell me, if you are given these 10 items to memorize, how do you actually memorize them?
For me, usually I will remember the first syllable, and then I try to remember the sequence of the syllable, and then I try to think what's the syllable like stand for. Like, let's say the first one, avocado, I think of A, and then second B, and then second also B. I'll try to think like that.
Great. You have your own method, which is very good. Right. Most of the students I taught, they do not have a very systematic method, and the common method that they use is to write it down, and write it down maybe 200 times, and hope that this will stick. Right. And unfortunately, this way of doing memorization is not going to work well with your brain, because human brain doesn't work well with text. Human brain doesn't work well with boring things, right? So human brain works well with what? So human brain works well with space. So if I tell you to imagine, close your eyes and imagine the items that you can see in your room. Just imagine that you are in a room. Where is the curtain? Where is the bed? Where is the door? Where is your wardrobe? Where is your study table? You can imagine it and know exactly where are those items being located easily. Take another example. Imagine that you are in your classroom. Where is the door? Where is your best friend sitting? Where is your crush sitting? Where is the window? And where is the whiteboard? You know it exactly. You can locate all of them easily. Why? Why human can do that easily? Because that's how the brain works, how human brain works. But we have been taught to, if you want to memorize something, you have to write it down like 200 times, and then hope that this thing will stick into our mind or our brain. Right. And another thing is, that's point number 1. So human brain works not in terms of text. Human brain works in terms of space. Another point is human brain works better with emotion. Imagine if today there is something very emotional happen. Maybe there is pink Pokemon. I think maybe some of you play Pokemon. I'm not a Pokemon player, but a pink Pokemon. Most of you are girls here, so I'll just use the pink color. Pop up in front of you. I think everyone will remember this day for the rest of your life because it is just unique and it is emotionally triggered for you to be able to to get this pink Pokemon that you love it so much and happen to be appearing right in front of you, right? So that is emotions. When there is emotions plus informations, that equivalent to long-term memory, right? So now let me make a test. Let us have 1 minute, and you tell me what is number 1 and until what is number 10. What is number 1? Number 2? Number 3? Xian, you remember? Number 4? 5? 6? 7? 8? No one remembers anything. I think at least you remember. Wait, let me admit somebody here. Right, I'll continue. I think maybe at least you remember the dark chocolate. Right. Anyway, for the sake of the time, I will just go straight without teasing you on certain questions. Right. Now, remember I told you that there are two important information over here. One is the equations, and one is the space. That's how our brain works, human brain works. And how I'm going to teach you this method, and you'll be able to remember them, 10 of them in sequence. Just now, if you have done the exercise by yourself silently, maybe you will be able to get 1 or 2 correct. Usually, that is the answers, or that is the result that we got for a first timer who is doing this test. Right? You get avocado, you get blueberry, and that's it. Or maybe you get the last one, the dark chocolate. Right? So let me review this method now. The method is you remember there are space. Everyone has a body part, right? Has some body parts. So I will select 10 body parts from our body, and then I'll associate it with the informations. Once I do that, I will add emotion in it, and then that will automatically create a long-term memory. So let's do that. Let's do. I'll turn on my camera so that you can see because it's related to the body part. Hello, everyone. Right. So number 1 is the head. Let's take head as number 1 body part. You have a big avocado that you slice into half, and you squeeze the avocado into your head, and the juice just rush out from the avocado into your eyes, into your nose, into your mouth, into your ears. It's just very sticky, and it's not a good feeling, right? Now you see what I'm trying to do. I'm trying to trigger emotions. Number 2, blueberry with the nose. With the blueberry, imagine the blueberry that is small and blue, the circle thing, and it went into your left nostril and coming out from your right nostril. So it's very painful, and it's not a very good experience, right? So that is the emotion that I'm trying to trigger to embed it with the information to create a long-term memory. Number 3, broccoli, mouth. Imagine broccoli. Broccoli is so big that it is growing out from your mouth, and you can already know that it is very painful to open your mouth to that kind of size. And yeah, you can see that I prefer to choose the negative emotions rather than the positive emotions, because again, human brains also attract to negativity more than positive. So that's why, because now we are trying to teach you the method, not trying to tell you to be thinking more positively, right? So I go along the flow with how human brain works. Number 4, coconut milk. Coconut milk, imagine your ears growing out to coconut tree, and the coconut milk drop down with the tick, 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 tick sound on the ground. Number 5, eggs. Imagine you pull out eggs from your neck, and that egg hatches a pink little chick. Number 6, salmon. Imagine there's a salmon that is on your neck, and it is still alive, and it is jumping left and right on your collarbone. Number 7, the green vegetable. Let's do something more disgusting. Your armpit. Imagine the armpit is growing out green vegetable, and you pluck it and you eat it. Okay, that's number 7, green vegetable. Most disgusting one. Number 8, curry powder. It's on your finger. You accidentally eat it and you blow out fire because it's just too spicy. Number 9, peanut. P sounds like the PP, okay? So that's where you pee your peanuts out. Number 10, let's make a bit more disgusting. Your backside with the dark chocolate, then you can do your own imagination, right? So we only take 3 minutes to explain this method. Now, let's see what is the result. Whether you can still remember 1 to 10. Number 1, what is number 1? I need somebody to tell me. Maybe
Avocado.
good. Number 2,
Blueberry.
great. Number 3,
Broccoli.
number 4,
Coconut milk.
number 5, what is number 5? You're pulling out something. Eggs. Number 6, what is number 6? It's on your collarbone. Number 7, your armpit.
Green vegetables.
Number 8,
Curry powder.
number 9, sounds like something that you do in the toilet. Yes. Number 10, dark chocolate. Right. So I think, how many of you got 10 out of 10? It's not impossible to get 10 out of 10. Most of you got definitely more than what you had before, 1 or 2. So that effectively increased your memory by more than 2 times, 3 times, or sometimes even 4 times, depending on how much you get in the first attempt. Right. So let's move on. Procrastination. Procrastinations. This you're going to stop procrastinations. Right. I will continue. This is going to stop procrastinations. Like I say, you take, okay, when you read, at least from my point of view, I'll just stop. I can open the video. It's okay. When I study during my high school time, how I study is I'll take the book for this chapter, and that if that chapter is 50 pages, I'll read those pages one by one, and I'll jot down some notes. And when I jot down those notes, these notes are the one that I will be reviewing them and revising them later, because it doesn't make sense to keep reading that 50 pages every time I need a revision. So that note is very important. And that note maybe is 2-3 pages or 1 page, depending. But whether that note is reflecting 100% of this 50 pages content, I don't know. I'll only know it when I go to the exam hall. And if I discover there is a question that I have no idea what it's talking about, then I know that my notes is not reflecting 100%. And that is already too late. Right. Some of the brighter students will maybe do this exercise or do past year questions and discover that there are questions that they cannot understand, and that means that the notes that they have been reading is not fully covering the 50 pages content. So they will add in more important key points into her notes. So you have to do this iteratively, right? Iteratively. You have to do this iteratively. And this process will take not 2 hours. This process will not take, it will take not 5 hours. This process takes days or weeks, right? Do you agree? This is how most of the students study. Can I have some response? Yes. Right. So just now, we established the fact that you would take maybe 2 weeks to study one chapter, to study well. So what's the chances of you procrastinate? Procrastinate is you're delaying or putting off something you need to do even though you know you should do it. If there's something that you need to do is 2 weeks, what is the chance of you going to procrastinate? The chance is higher. It is high. And definitely higher than something that is going to take you 1 second to do. Right? That is logic. If there's 2 tasks, one task takes 2 weeks and one task takes 1 second, what is the chance of you procrastinating on the task that is 1 second? Almost zero. Because by the time you want to think about how to stop you from doing that, you already done it. But if it is 2 weeks, the chance is high. So what is BrainDrawer is going to help you is to reduce these 2 weeks into 2 hours. So when it is 2 hours, what is the chance of you procrastinate? It's definitely lower than the 2 weeks, right? And the flying brain problem, we have already done this. We already done this. So you know what is flying brain problem. All right. So let's go to the core of it. Now we have already explained the principle behind the study, the BrainDrawer method. Next, we will go into the quantum physics. We will use BrainDrawer to study quantum physics. So there will be another 2 hours. Can I have full attention from you girls to have this 2 hours to be with me? Can I have that commitment?
Okay.
All right, let's do it. Okay, let me open the notes that is relevant to this. All right, so there are 9 steps. Let's start with these 9 steps. With step 1. Step 1 is create drawers. In quantum physics, okay, first of all, this quantum physics is SPM, is a chapter 7 from SPM, form 5. And for some of you, you're not form 5 yet, or you're not year 11 yet, so maybe you find it a bit difficult as a start, but don't worry. Everyone have the same feeling. You feel that you know this more and more as we progress to the third, or for the 7 or 8 steps. But I need you to commit to have your full focus with me so that I can help you to show how this BrainDrawer works. Once this BrainDrawer works with you, then you can repeat the same step with other chapters in your own subjects, whether it's year 9, year 8, or form 1, form 2, form 3, it doesn't matter. Right, so let's start with the first one. Create drawer. There are 3 drawers that I will be creating for this chapter, quantum physics. Number 1 is quantum theory of light. Number 2 is photoelectric effect. And number 3 is Einstein photoelectric theory. Right, so there are 3 drawers. Wait, okay, someone is coming. Okay, it's okay, right? So I'm sorry, I'm distracted a bit. Right. So how do you remember these 3 drawers easily? Remember I told you information plus emotion equivalent to long-term memory. So let's build a short story. Here a simple story to connect them. Einstein walks into his room and switches a light bulb. Einstein represents the 3rd drawer. Switching on the bulb represents the electricity, electricity. The bulb that is glowing, the light, which is representing the quantum theory of light. For now, you just need to have this quick image. Einstein electric switch, and light. Is it clear? Einstein walked into a room, turn on the switch, and turn on the light bulb. And there are three, it's representing the three drawers. Now, let's go to the sticker technique for visualization. Let's imagine there are three drawers right in front of you. Left, middle, and right. Left, middle, and right. In front of you, there is the left drawer. You can put any, you can color it with the color that you like. The middle drawer and the third drawer. The first drawer is called quantum theory of light. The second drawer is the photoelectric effect. And the third drawer is the Einstein photoelectric theory. Right. So these are the three drawers. Now I want you to put a sticker on each of the drawer. Stick a glowing light bulb on the first drawer. So in your first drawer, there is a door. Take the sticker and stick it on the first drawer. Number 2 drawer is about photoelectric effect, and it's about this electricity, the switch. You remember Einstein's turn on the light bulb by turning on the switch. So for electricity, use the yellow thunderbolt sign. You know, when you walk near to TNB box. TNB is like the National Electric Company box, and you see this danger sign, instantly it makes you think of electricity, right? So take that sticker and stick it on your second drawer. That's right in front of you. Third drawer, Einstein. For Einstein, picture a man with a messy hair and a big nose. Albert Einstein himself. Stick his face on the third drawer. All right. So now we have 3 drawers with 3 stickers. Einstein, the thunderbolt sign, and also the light bulb. Right. So let's recap. The light bulb equivalent to the quantum theory of light. The thunderbolt is the photoelectric effect. The Einstein phase is the Einstein photoelectric theory. That's it. We complete step number 1. Is it easy?
Yes, yes.
Okay, good. Now let's go to step number 2. I'll turn off my camera so that you can have better internet. So let's go to step number 2. I have to bring up the keynotes. Okay, I'll put them side by side. So these are the keynotes. These are keynotes about the 3 drawers. You still remember we have 3 drawers: the quantum theory of light, the photoelectric effect, and also the Einstein photoelectric theory. Now we have to fill information or fill items in the drawer. Imagine that you are opening up your first drawer. Open the door for the first drawer that is having this sticker of the light bulb. Now what do you see inside? It's empty. It's totally empty inside. You do the same thing. You open the second drawer that is having the thunderbolt, the electricity, the photoelectric effect. What is inside? Nothing inside. It's empty. It's an empty drawer. The third one, the Einstein photo, the picture, it is also empty. All 3 drawers are empty. This is where we will try to fill up informations and fill up images and fill up items into that drawer. Right. So let's read this quickly, and then we'll see how we can translate them into keywords that can put it into the drawer. There are 5 points over here. It's very easy. Don't worry too much about fully understanding it. Right. Just read them and get some keywords, and that's it. That's it for now for this step number 2. Back body radiation absorb all magnetic radiations fall on it. Temperature and emission: cold object low frequency, hot object high frequency. radiation intensity versus wavelength, high temperature, short wavelength. I think for most of the people over here, it makes totally zero sense, right? No problem. For this point number one, what is the keyword that stands out? I think is the black body, right? So now imagine a black body in front of you and pick up that black body, put it inside the first drawer. And that drawer is the drawer of having the light bulb sticker, quantum theory of light. All right. So now the light bulb drawer is having one item, which is that black body that you just put in. Now continue. Number two, classic theory flaw, predicted unlimited energy at high frequencies, but experiments shows that it wasn't true. Ultraviolet catastrophe. Same thing. I think most of you also doesn't have any clue what is this about. Don't worry. You will come to light when you go into these steps. Right. So what we need to do now is just to pick up the keywords. What are the keywords that stand out? Maybe ultraviolet. Right? Ultraviolet is something I can associate with something that is blue or purple. So take that device that is blue or purple, or blue and purple, and put that ultraviolet device or the item into the first drawer. Okay. So now in the first drawer, we have two items, the black body and also the ultraviolet. Number three, scientists. So there's a list of scientists over here. Isaac Newton, Thomas Young, John Thomson, Planck, Max Planck, Albert Einstein, the smart guy, and all of them are smart. So some of the scientists, you know them by name. Some of them you have no idea who they are. Now there are a bunch of scientists in front of you. Invite them into your first drawer. Now your drawer is not just a small drawer that you put your books or you put your items in it. You can expand it to something that is bigger than that. Now invite all these scientists into that first drawer. So now your first drawer is having three items: black body, ultraviolet, purple color, and a bunch of very important and top scientists in the drawer now. Are you following me? Anyone left out? Is it interesting so far? Elise, are you still with me?
Yeah.
Okay. But you are following, right? Everyone is following, right? Shian, Elise, Jovin, Xuan, Venice, Tivia, Paris, Jahani. Okay, I'll assume everyone is still with me because I think it is very easy to imagine that what we are doing now. Putting items into your drawers. That's it. Very simple. Don't worry too much about understanding all of them yet. Like I said, you will know them later. Now, next, let's go to next. Quantum energy, discrete energy packet, and not continuous energy. No idea what is it talking about. Photon are light energy transfer in quantum energy. Oh, it's even more advanced. Okay, and there is a formula over here, and there's a Planck constant, and there's a line spectrum produced by an excited atom. It's a series, blah 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 blah. Okay, you can read it by yourself. But now we want to pick up the keywords. What is the keywords that you can pick up over here? For Malaysians, I think everyone knows the car proton, right? At least maybe you also know the car proton. Yeah. So quantum energy, I cannot get any keywords. Even if I take quantum or take energy, it's something that I cannot translate into some item that I can put it into the drawer easily. So I took photons, which sounds like proton. So I drive that proton car and I put it into my drawer. So that drawer now is having four items: the black body, the purple color ultraviolet, a bunch of scientists, and a proton car inside that drawer. Right? So let's move to point number 5. Wave particle duality. I'll let you read for 30 seconds. Okay, read this for another 15 seconds. Excellent. I'm sure most of you also do not understand what is it. Make no sense, but it's fine. Let's take the keywords. What are the keywords? I'll take the keyword wave particle duality. Wave particle duality means they are, I'll take a coin that is having two face. The first, the face on the one side is showing the wave, like the gelombang. Gelombang is a Malay word, sorry. It's a wave like, you know, in the ocean, the wave, right? So there's a picture on that one side. On the other side of the coin is the particles. What is particles? Particle is something that is something like a ball, small. So you can imagine there are many balls or many round object that is on the other side of the coin. So there's a coin that's having wave and there's having particles, which is the round object. Right. Take that and put it into your first drawer. So now we completed drawer number one. Drawer number one, we have 5 items. The black body. Okay, now open the doors. Imagine that you're opening the door of the first drawer and look inside. What do you see inside in the first drawer? You see the black body. You see the ultraviolet. You see a bunch of scientists. You see a proton car. You see a coin that is having 2 faces. Right? So now close that first drawer and open the second drawer. What do you see inside now? The second drawer has nothing because we haven't built that. So let's do the same exercise and put in information into that drawer. So let's read this. I'll give you 10 seconds to read this. All right. I'm sure for most of you also, it doesn't make sense. Even after reading it for 200 seconds. But let me create a story for you. So it will help you to understand this definition of photoelectric effect better. I'll read it first. Phenomena where electrons are emitted, photoelectron, which is called photoelectron, from a metal surface when it is illuminated by a beam of light at a certain frequency. So imagine you have a torchlight that is showing, that is beaming on a metal surface. And that metal surface apparently is having an eye, mata, 眼睛, okay? And when that torchlight beam into that eye, the eye pops out. Okay? So that is describing the definition of photoelectric effect. Let's see. Let's see whether this story makes sense now. Photoelectric effect is a phenomenon where electron is the eyes. Remember the eyes that I said just now? That I mentioned just now? Are emitted. Emitted means pop out. And when the electrons that are being emitted, it is called photoelectrons. So the pop out eyes are called photoelectron. Pop out, pop sounds a bit like, you know, photo, P. So that's how I relate them. And from where? This eyes that is pop out from where? From a metal. And how it is being pop up? It is when illuminated by a beam of light at a certain frequency. Right. So I'll tell you the story again. A torchlight shine on a metal, and that metal's eyes pops out. Okay. So I think everyone is following, and that is to describe this definition. Now, take this torchlight with the pop out eyes metal, put it into your second drawer. Right. Now, third drawer. Still second drawer, the second part. Let's read this for another 10 seconds. All right. I think again also it doesn't make sense for most of you here, but like I say, it doesn't matter. Let's take the keywords. So the keywords here is characteristics, and this characteristic is having some very technical terms that let's not worry about memorizing them, or let's not worry about understanding them for now. I'll take this characteristic as like character, cartoon character. And there are 4 cartoon characters that I need to know. I need to put it into my drawers. Right. So what type of cartoon characters? When I see these 4 informations, they are related to kinetic energy. Kinetic energy means movement. Right. They are related to instantaneous emission. So instantaneous pop out. So it's more or less like a movement. So imagine there are 4 cartoon characters jump into your second drawer, right? Jump into your second drawer. So let's ask these 4 cartoon characters and jump into the second drawer. So now the second drawer is having the torchlight, the pop out eyes, and 4 cartoon characters. The third one, higher intensity, brighter light, bigger current, high kinetic, deeper penetration. So higher intensity, brighter light means now you have a bigger torchlight that is more powerful and brighter. So take that torchlight and put it inside your second drawer. So now let's review a bit. Your second drawer, how many items do you have now? You have that torchlight that is beaming on the metal and the eyes is being popped out. Then you have the 4 cartoon characters that jump into your drawer. And then you have a bigger torchlight that's brighter. Okay? Close that first, the second drawer. What is the second drawer's sticker? What do you see there? The sticker. You still remember the sticker? The sticker of the thunder sign, danger. Yes, that is on the first, second drawer, the sticker. Right, and that sticker is representing photoelectric effect. So now you have first drawer, quantum theory of light, filled with all these items, the 5 items. And you have the second drawer, photoelectric effect, filled with three items, 1 story and 2 items. And then the third drawer. Let's do this drill again. The third drawer, when you open the third drawer, there's nothing there, empty. Let's fill them up. Okay, I will have 10, 20 seconds. I think 20 seconds is better. Let's read this by yourself, silently. Okay, 20 seconds up. Again, I think it doesn't make sense for most of you also, even after you read it for 200 times. Right, so let's pick some keywords. The keyword is the work function, and the keyword is the kinetic energy. So what is work function? Let's not go into detail first. I think most of the students here doesn't like to do homework. Anyone like to do homework? No one. There's no response. Okay. So imagine yourself, whether you are Elise, whether you are Xuan, whether you are Xian. Imagine yourself walking to your classroom and do homework that you did not like. You hated so much, right? So this work the keyword work here, let's translate it into the homework that you need to do in the classroom. And how do you go to the classroom? You walk. And you walk means you need to have some kinetic energy. Kinetic energy is motion. Okay, you have electric energy, you have magnetic energy. Now we're talking about kinetic energy. Kinetic energy is when you have motion, when there's something moving, there is a kinetic energy, right? So you walk to the classroom to do homework. So that is to reflect the work and to reflect the kinetic energy keywords. And this is the formula. Don't worry about the formula. Just see like a very cute formula now. Don't need to memorize them. Then applications. Application, we can just take it as the words, the terms itself, solar cell or solar panel. So pick that solar panel and put it inside your third drawer. Pick that electric door and put it inside your third drawer, and pick that microscope and put it inside your third drawer. So what do you have in inside your third drawer? You have the solar cell, you have the door, you have the microscope, and also you have yourself walking to the classroom to do the homework. Right. So close the door of the third drawer. Now, let's do a quick review. Xian, first drawer. If I open up your first drawer, what do you see inside the first drawer?
First one, a black body.
Yes.
Second one, ultraviolet. Third,
Excellent.
many scientists. And then fourth is
Which car?
the coin. The car, and then the next one is coin.
The proton car, our national car. Right? And then the coin. Yes. Excellent. I'm going to test another student. Who wants to volunteer? The second drawer. What do you see in the second drawer when you open the second drawer? Nobody's want to volunteer. I will pick. Okay, please. Please, Faris.
Torchlight.
Okay, what else? You have the torchlight. What else?
Cartoon characters.
4 cartoon characters. Excellent. TV, yeah, I saw you. Right, 4 cartoon characters jumping into the drawer, and you have the torchlight beaming on the metal, and the metal is having an eye, mata, yanting, and that eye pops out. Right, and then you have a bigger torchlight. So you have 3 things here. You have that small story, which is the eyes, the pop-out eyes with the smaller torchlight. You have 4 cartoon characters, and you have a bigger torchlight. Now, third drawer. What do you see inside the third drawer? Can somebody volunteer? I will pick. Who should I pick? Okay, I will tell you the answer, but on the next step, I will pick. Why do I want to do that? Because I want you to be on your toe, to listen, okay? And like I said, you gave your commitment that you are going to focus for 2 hours, right? 2 hours, and I'm sure you're going to get what you need. As yeah, I saw something. Going to, yes, Shren, yes. Going to your classroom and do your homework, right? And then also you have some solar panel. You have some automatic door, and you have some Microsoft. Yes, microscope, not Microsoft, sorry. So let's close that drawer. Now, these 3 drawers are filled with items. Excellent. Shen, I saw that, yes. So now let's go to, so this is done. Isn't that easy? This is done. Next 3 steps is a bit heavy on reading. So I also need you to recommit yourself to read a bit more than step 2. Okay, so don't feel that it is boring, but just focus on the next step. Let me open this. I'll put it side by side. The keynote is very important. You will be using this as a reference to refer on the drawer, so that the drawer and the items in the drawer will be very familiarized to you. So that's the point. Right. Let me just readjust myself on this notes. Put this in. I'll take a few more things with techniques. Where's the techniques? Sorry, just give me a few more seconds. Okay, I'm back. Right. So step number 3, read summary. So what do we do? Let's look at the technique. Look at the technique, the red color technique. This is to help you on the trainable skill number 3. For those who came late, maybe you do not understand which are the skills that we are trying to teach. We're trying to train here, but just try to follow as we progress. So trainable skill number 3. So those who were here from the first part, remember there are 3 skills. First skill is your knowledge base. Second skill is the fast recall. Third skill is how you store your information. This is going to train your third skill, how you store your information and how you store it in the right location. For our case, is in the right drawer, and maybe in the right sub drawer. Okay, so how do you do that? Number 1, you need to read the notes. The notes is the one on your right, which is step 3, read summary. So we have parts by parts. You have to read those notes part by parts. And then once you read those notes, you need to identify which drawer it belongs to. Right? You can do a cross-reference with the keynotes here. This is a keynote. On your left is the keynotes. On your right is the summary notes. Right? In the middle is how do you do this. So once you link it with the drawer, the third step is this a new information or is this new understanding? If there is new information or new understanding, intentionally pick those information or understanding out and put it inside your own drawer. Right. By the end of this, everyone will have different items or different stories or different images inside your drawer number 1, because everyone has different level of understanding and has a different level of preference. What is the keywords that you need to pick up from here and to put it into the next drawer, put it into the first drawer. Right. So I hope everyone understand how this works. If you don't, I'll keep these techniques over here so that you can refer it back how you should be doing this. Right. Anyone have any question? How to do this? I hope no, right? Because I did not get any answer, any reply. Now, I'll do this one time with you. So this is the first part. The first part is let's read this together. The quantum theory of light. Black body radiations. Obviously, this is if I ask you the questions to identify which drawer. Can anyone tell me which drawer is this related to? Drawer number 1, number 2, or number 3? The first drawer. Excellent. And it is related to the first sub drawer or the item, the black body that you just put inside the first drawer, right? Now, continue reading the notes, like is in the technique. Step number 1. Point number 1. Read the notes. So black body is an idealized object that absorbs all incident electromagnetic radiations. So it absorbs all electromagnetic radiation. For the younger student who doesn't know what is electromagnetic, don't worry. You just need to know that there is some type of radiation, or some type of energy that is being absorbed by this black body. And once it absorbs, it emits. Emits means keluarkan, means output, emits. Okay. Thermal radiation depending only on its temperature. Right. So it absorbs and it emits. Electromagnetic spectrum, continuous spectrum, and you have radio, microwave, infrared, visible light, ultraviolet, X-ray, gamma rays. Gamma ray is having higher frequency than radio, and is of this sequence. Radio is the lowest frequency, and then it's go on to microwave, infrared until gamma. Right. So those are the new information or new understanding that you need to intentionally pick it up and put it inside your first drawer and first sub drawer. Right. Let's continue. Another example. Temperature and emission. Cold object emits low frequency. Hot object emits high frequency. So hot, panas, which is 热. Okay, hot is high frequency, cold, low frequency. So this is new information. Maybe you haven't translated into understanding yet. You do not understand what is it, but don't worry. Just pick up those new information and put it inside your first drawer and subdrawer number 1. First drawer and subdrawer number 1. Then you have intensity and wavelength. Increased temperatures shift the peak of radiation intensity to shorter wavelength. No, doesn't make sense. Don't worry. Okay, you will be clearer later. So intensity and wavelength. What you need to do is when there's an increase in temperature, and then they will radiate intensity to shorter wavelength. Increase in temperature, shorter wavelength. Simple. Increase in temperature, shorter wavelength for this for now. Right. So this is how we are going to do for this first part. Read the note, identify which drawer, ask yourself whether there's new information or new understanding. If there is, pick it up and put it inside the right drawer, which for this case will be the first drawer and the first sub drawer. Is that clear? We're going to do this drill for maybe 7 times. I hope it's clear. Is it clear? Anyone is not clear? Yes, it's clear. Okay, good. So let's go to this part here. I'll leave it to you to read this and then do these 4 parts. Let's start now. Let's do 30 seconds. Okay, can somebody tell me which drawer is this? Which drawer is this? You can refer to this keynotes from the left side. Which drawer is this?
1.
Drawer number 1. Yes, excellent. Which sub drawer? We have 5 sub drawers. Is it black body, ultraviolet, scientist, or the proton car?
Scientist.
Excellent. All right. So that is the scientist. And I think usually a Malaysian student, if you see table like this, you would tend to memorize each of them and also in sequence, and also with the years, this year, and also what are their contribution. Remember them like each and every alphabet. This is the wrong way to study, because like I say, after 2 weeks you forgot all of them. How do you study this? My method is I'll see this. Okay, there are a list of scientists, and these scientists, I know Isaac Newton is the oldest, and Lewis is the youngest. Albert Einstein is somewhere in the middle. They divided into 2 types of contributions: the classical physics and the quantum physics. So this tells us that classical physics is the old physics. Quantum physics is the new modern physics, right? Because the younger scientists are contributing in the quantum physics rather than the classical physics, and the older one, vice versa, right? So that's it you need to know. The details will come later. That's it you need to know. All right, so let's continue the following parts on this. Do the same drill. If you've forgotten what you need to do, read the techniques and do it. I'll give you 30 seconds. If you need more time, then you have to tell me. Right? Some people are slower reading, slower readers. Some are faster. But that's not the point. We are not doing a competition over here. We are trying to help you to do this, to train your skill number 3. Right? So have you done this? Which drawer? Xian, which drawer? Give a guess.
First drawer.
Yes. What is the name of the first drawer?
The quantum theory of light, the light bulb.
Yes. The light bulb. Yes, excellent. And it's associated or is linked with the quantum energy drawer or the proton car drawer. All right, because it's talking about the quantum energy. So what does it say? It says about quantum energy equivalent to discrete packet of energy. Discrete means it's not continuous, opposite of continuous, right? And what else does it say? Light consists of photons. So the lights, inside lights, there's photons. What is photons? If you don't understand, don't worry yet. You just know that there is something called photon that's inside the light. Right, and each carry energy proportional to its frequency. Okay, so the photon is having energy, and somehow the energy is proportional to the frequency. If you don't understand it fully right now, don't worry. Still, you just need to know that there is a photon in the light, and there's energy that's proportional to its frequency. Right, and also this quantum theory, you have some scientists. This part is related to the the third subdrawer, which are the scientists. So this development until this wavelength part is linked to 2 subdrawers. The quantum energy drawer, number 4, and the third drawer, third subdrawer, scientist. All right. So if there is any new information that you think is important or new understanding that you have already formed, pick it up intentionally and put it into the first drawer, the theory of light, the quantum theory of light. All right. Let's do this drill again for this part over here. If you've forgotten the techniques, it is here, the red color. I will give you 30 seconds. All right. Which drawer is this? Anyone? Tavia? You're still with us? Or anyone? Anyone else? Venice? Elise?
I'm not sure.
You're not sure? No worry. We are here to help. Wave-particle duality. Wave-particle duality, where do you see it here? It's in the first drawer. Wave-particle duality is in the first drawer, right? And it's the subdrawer of number 5. And what was it related to? You remember the coin, the 2-sided coins, the wave and the particles, right? That is the image that you can remember. You can link with this particle duality. So what does it say? It says that the light exhibits both wave property and also particle properties. What do I mean by wave properties and particle properties? Have you been to a swimming pool and you push the water from the swimming pool? What does it create? It creates wave. If you put an obstacle in front of the wave, what happened? The wave pattern formed to another pattern, right? Because there is an obstacle there. And that is a property that only wave has. And those are called diffraction and interference. If you don't understand diffraction and interference, it's fine. You just need to know that there is a wave properties that is exhibit in the light, right? So there's this wave property. And also they are saying that light is also having a particle property. What is particle property? So now imagine you push not the water, now you push a ball. When the ball hits an obstacle, what happened? It will reflect. When the ball hit the wall, it will reflect. It doesn't turn into another form. The ball doesn't turn into another form. But wave, it turns into another pattern. It turns into another form, right? So particle property and wave property, usually they are not the same. But this is explaining wave particle duality as light is having both the properties, the wave properties and also the particle properties, right? That is the theory, the quantum theory of light. All right. So this is the new understanding. I would say that this is a new understanding. Pick this up. Whether you want to form it in the story of you are pushing the water and you're pushing and you're pushing the ball, and put it into the first drawer and the fifth sub drawer, the drawer that's related to the double-sided coins. Is it clear now? Clearer now?
Yeah, a bit.
Yep, you got it. All right. So let's repeat the drill for this part. Photoelectric effect. I'll give you 30 seconds to read. Done. Yeah, before that, what time did we start just now? I remember it was 3. Oh, in Riyadh time, it was 3:45. Or what is it? What is the time like? 8:45. Start means starting learning this quantum physics, not the principle of the BrainDrawer. I think it's about that time. So we are not even 1 hour, right? You promised me to have 2 hours. Okay, so let's do that. Let's focus on the 2 hours, and then let's see whether you get the result that you want. Can somebody tell me which drawer is this?
Second.
Yes, second drawer. And it's the cartoon. And actually 2 drawers, the cartoon drawer and also the story, the small story, right? This part is the small story. The torchlight that is beam on the metal, and the metal's eyes pop out. And then this part is talking about the 4 cartoons, the jump into the drawer. So you have what? You have kinetic energy proportional to the frequency. You have the threshold frequency. You have the independent of intensity. You have instantaneous emission. Right. Don't worry about memorizing this. I'll create a story for you to understand this better. For now, you just need to read this and try to understand as much as you can in that 30 seconds. If you identify new information, put it inside your second drawer. If you're able to form into an understanding, new understanding, excellent. Put it inside your second drawer, which is the photoelectric drawer, which is a thunderbolt. Right. So next, I think we only need 10 seconds. All right, which drawer is this? This is a very easy question. Anyone? I have to keep yes, strength is good. It's third drawer. I have to keep reminding you on the drawers because it was done. I have to design it this way. So don't be frustrated, feeling that I'm asking repetitive questions. It is done intentionally. right? It is time intelligent because once you form the drawer and you have a very clear clarity on the drawers, this will help you in the further steps. This will help you to understand the chapter very well, right? So bear with me. We all have another 1.5 hours. Just bear with me for another 1.5 hours, right? Yes. Drawer number 3. Yes, excellent. And drawer number 3 is the Einstein photoelectric theory. The sticker is the Einstein face, the guy with the messy hair with the big nose, right? And what is it talking about? It's talking about a photon transfer all its energy to a single electron. What is this? It's talking about a photon that is inside the light transfer his or her energy, and this is a guy or girl, to another electron. Maybe you can imagine photon is a guy. He transfer his energy to a single electron, and that is a girl, right? Energy distributions, okay? So you have this work function and also kinetic energy. At this point, you still do not know what is work function. Don't worry, you're gonna know it later. At this point, you just need to know that there's a homework that you need to do because you have to walk from your house to the classroom, for example, right? And that's related to kinetic energy. Now let's do this. 10 seconds. If you've forgotten the techniques, then you can refer here. Or 20 seconds. Let's do another 10 seconds. All right. Which drawer? Anyone? 4th drawer. Taviva, there's no number 4. We only have 3. Mana datang number 4. Yes, number 3. Okay. Number 3. Work function is Einstein drawer. Yes. Okay, I see your corrections. Einstein drawer, number 3. Right? Einstein drawer, when you open the drawer, what do you see inside? You see yourself walking to your classroom, very unhappy and trying to do your homework. And what else do you see? You see this application which is not relevant for this case. So now, let's break this down a bit. Work function. What is this work function? Now is the time for you to get new information. Minimum energy required to release an electron. Right? Minimum energy required to release an electron. Is this a new information? If yes, pick it up and put it inside your 3rd drawer. Right? So there is a minimum energy that is needed to release that electron. Right? If you do not fully understand yet, don't worry. Just understand it as the new information for this case. Right? Ask yourself, is this a new information? Yes, put it in. Or if you are able to form it into a new understanding, then it's even better. Right? Then there are some formula over here with H, which is the Planck constant, and also F, which is the frequency, the threshold frequency. Now we're almost there. We almost finished the step 3. So let's do this. Let's read this for 10 seconds. Do the same techniques. All right. Okay, so there's this drawer number 3, Einstein drawer, photoelectric theory, the drawer of photoelectric theory. So there's this formula that they are explaining. So let's go through it quickly. HF is the photon energy. Remember just now on the previous few questions, they describe about the photon energy, right? So there's a photon energy, and then there's a work function, and then there's a kinetic maximum, which is maximum kinetic energy of the photoelectron. I imagine this with this very short story, let me tell you the short story. You have an energy that is equivalent to 100 watt, okay, whichever unit that you want to put it as a label, 100. And if you want to push the electron out, first you need to have a threshold. You need to have a threshold first. There's an entry ticket. The entry ticket, you need to pay 30 ringgit or 30 real. Right. So let's repeat. You have 100 ringgit. And that 100 ringgit is used to buy something. First, you need to buy the ticket to go into the shop to buy something. And that shop is the entry ticket is 30 ringgit. And then the remaining is 70 ringgit. Right. So translate it into a photon energy transfer. Photon is having this 100 energy. When it's beamed into the metal, and the metal will pop out the electron. You remember the pop out eyes? Right. The energy will transfer now. Will transfer into the electrons, which is the pop out eyes. Right. But before that, you need to pay some energy as the minimum energy to pop out that electron, to emit the electron. The remaining energy, after minus the work function, is the maximum kinetic energy of the photon, of the electron. So when the electron pops out, it is very excited. So what is the energy that he has now when he is too excited? So that is the maximum energy. Energy of the photon equivalent to the minimum energy that you need. And then that is the remaining of the kinetic energy for the photons, right? I think you have new understanding for this. Pick this new understanding and put it inside your third drawer. The third drawer that is having the Einstein picture, and the third drawer that is having the story about you going to your classroom to do some homework, right? Next, this will be the last one for step number 3. Let's read this in 10 seconds quickly. All right, which drawer is this? Xian.
The third drawer.
Yes. What's the name of the third drawer?
The Einstein.
Excellent. All right. So now let's go to step number 4. Now is what is the time now? 9:30. Right. So we have done almost 1 hour. We still have 1 more hour. Let's do it quickly. I know the concentration is low now, but just give me another 1 hour. Another 1 hour. Once we've complete this, then you'll see a bigger picture of understanding on this chapter. Right. So how do you do this? Every time there's a technique, there's a process that you need to follow. And this process is going to help you also to train your skill number 3, store new information. So how do you do that? Read the question. This is FAQ. FAQ is frequent asked questions. And then you read the question. There are 8 questions. Read the questions. Before you read the answer, identify which drawer is this. Then read the answer and ask whether this is a new information or it is a new understanding. Then place it inside the correct drawer that you identified just now. Right, can we do that? This will take maybe another 15, 20 minutes. So let's concentrate on that 15, 20 minutes. Let's start. I'll give you 30 seconds to read. Okay, I hope you did the drill with this red color techniques. And the drawer, you identify the drawers. Okay, and the drawer is drawer number 1, which is the quantum theory of light, and the subdrawer is the black body, and also the classical theory flaws. The classical theory flaws, right? Let me explain a bit. Number 2 is there are 2 types of physics. One is the classical physics, one is the quantum physics. The classical physics were having many flaws, and that flaws give birth to the quantum physics. And what are the classical physics flaws? They predicted unlimited energy at high frequencies. But experiment shows that this is not true. Right? This is explanation. This is the explanation why it says that this classical physics is having, or classical theory is having some flaws. Right? So once you read this, if there's new information, put it inside your drawer. If you can form it into an understanding, then it's even better. Put it inside your drawer as well. Okay, number 2. Let's do the same drill. I'll open up this technique if you've forgotten. Let's do 30 seconds. Okay. Which drawer is this? Anyone? Tell me which drawer and tell me the name of the drawer. Quickly, quickly. We still have 1 hour. See the keywords, quantum energy. See the keyword quantum energy here, which is the proton car. The proton car, photon. I use it as a proton car. So it's the first drawer, right? First drawer, the 4th item, the proton car. Second drawer, it is not the second drawer. It is not the photoelectric effect. It is the first drawer and this part here. Okay. Let's move on. Wave particle duality. This one I think Elise knows this by heart now. Let's read this in 30 seconds. Right, Elise, which drawer is this? Yes, the coin. First drawer. Elise, you're still with us? We still have
Yes,
1
the
more hour to
Wi-Fi is
go.
bad.
Your Wi-Fi is back. Okay. Can you tell me which drawer?
First?
Yes, first drawer. And it's the coin. Remember the coin? The coin that's having 2 face, wave and particles. In the Malaysia coin, you have the face of the parliament, and also I don't know, I can't remember. I have a long time. Last time was parliament and the 20 cents and the 20 cents number over there. Right. So for this coin, you have one side wave, one side particles. Now next, let's do this. 20 seconds. Forgot what you need to do, then read the red color techniques. Tavia, I'm going to ask you. Okay, Tavia, which drawer? Second drawer. Yes, good. And it's the cartoon, right? The cartoon, the characters. So these are the characters. So do you have? And also this is the remember the short story, where the torchlight that we are beaming the light on the metal. Just imagine the story, torchlight beaming the light on the metal, and the metal pops out the eyes, which is called the photoelectrons, right? Next, let's do the same drill again. 20 seconds. Faris, I'm going to ask you later. Be ready. Oh, it's done. Faris, which drawer?
That
I cannot hear you. Which drawer? 1, 2, 3?
three.
Ah, the 3. Yes, the third drawer. Yes, you're right. Okay. So any new information or new understanding, if you got it, new information, new understanding, put it inside your drawer. Because everyone's drawer are now different. My role here is to help you to form the drawer. When we started the drawer, it was empty. And then we have some items inside. We have the black body, we have the you have the UV, we have the scientist, etc., etc. Now I'm sure the drawer of Xian, the drawer of Xuan, the drawer of Elise, the drawer of everyone here are different. You have different items, different storage, different images. Right. Next. 6. We have 2 more to go. 3 more to go. Let's do this. Xian, I'm going to ask you later. Okay, which drawer, Xian? And tell me the name.
Third drawer, the Einstein.
Yes, very good. Third drawer, the Einstein drawer. Now, this is a bit tricky. I'm going to ask the, let's read first. I'm going to ask, read first. 20 seconds. I'm going to ask Xuan. Xuan, which drawer? If you don't know, it's fine. Just tell me you don't know. Second drawer. Second drawer. Is this second drawer? Anyone else? It's not second drawer. Yes, Sevilla is first drawer, right? It's about the formula here, and it's about the scientist. So it's a combination of drawer, this drawer number 3, sub drawer number 3 of drawer number 1, and the wave particle duality, right? Even the Broglie is mentioned over here. So it's not always associated to one drawer or one sub drawer. It could be a mixture. Okay, the last one. Elise, I'm going to ask you. So be ready. 20 seconds. Or 10 seconds. This is too easy. Okay, Elise. Which drawer?
Third.
I can hear you.
Third.
Which drawer? Third, yes, good. Third drawer and the last sub drawer, which is applications. So now you can also see that there are new applications over here, quantum computers, secure encryption and digital signatures, and image sensors. So you do not need to intentionally write it down in the keynotes, or you can form it into your own image and put it inside the drawers that you are maintaining right now. So that's why I say everyone's drawer now, the items or the story or the image inside these 3 drawers or the sub drawers are different, right? Because everyone have their own understanding. Now, this is step 5. Step 5. Okay, step 5, I promise you, is the last thing that you're going to read. Next, you'll be watching video, you'll be listening, it will be much easier. So let's go through this last step that you need to read and do the same drill. What is the drill? Okay, there are 2 parts here. Read the guide and read the quiz. So for now, let's focus on read the guide. Let's read the techniques, the red color techniques first. Whoever who haven't read this or cannot understand this, tell me. By now, you should be able to understand. If not, tell me, please. It's very important. Please read this one more time in 10 seconds. This one, the red color. Done. Okay. No question. I believe everyone knows what they need to do now, because we will run through the similar drill for, I think, like 3-4 times. Now, we will also do the same thing. Read one part by part, and then run the drills of the red color techniques. I'll give you 30 seconds. I'm going to pick somebody to ask. I'm not telling you now who. All right. Don't worry about being wrong, by the way. Venice, you have been very silent. Are you still with us? Maybe she's not. All right. Tabiya, which drawer is this? Yes, drawer number 1. And sub-drawer that's related to drawer number 1 is the black body radiation and is the quantum energy. Right. So when you read this just now with 30 seconds, is there any new information? I'm sorry, I'm repeating myself a lot of time on this, but because this is very important, that's why I have to repeat. Any new informations or new understanding is even better. Pick it up and put it inside your drawer. Right. Oh yes, let me repeat this. Maybe I'm not clear. This session is to teach you the study method. And we are using quantum physics to teach you the study method. It could be nuclear physics. It could be electromagnetism. It could be electronics. It doesn't matter. Once you know the study method, you can do it by yourself on other chapters or even on other subjects, chemistry, biology, right? So I'm not a physics teacher, but I use this method to be able to teach you quantum physics, and so that you can follow the step 1 until step 9. Then you can replicate it when you have more understanding about this, right? All right, so let's continue this. Okay, we're at this part here. All right, 30 seconds. I'm gonna ask 2 persons because there are 2 drawers over here. I'm gonna ask Elise and Xian later. Okay, Elise, Which drawer is this?
Second.
Which drawer? I did not hear you. 1, 2, or
Second.
3?
2.
The second drawer. No, it's not a second drawer. It's this one. Quantum energy. Right? Oh, there's a hint. Yes, there's a hint for you. Usually, this text is is done by sequence. Right? You see, this is the second drawer. So obviously, the one that is on top of it, maybe it will be the first drawer.
First.
Yes, yes. It always in sequence. If you go up, you see, if you realize it is in sequence, see black body radiations. Then you see the development of quantum theory, which is having the scientists. So it's here. Black body was here. Then it follows by quantum of energy, which is here. Then, as you would expect, Xian, it will be the next one that is coming, which is the wave particle duality. Right. Then you see the next one is the second drawer. Right. It's always in sequence if you realize this, because it's done intentionally that way. Right. So wave particle duality, answer for Xian, this is drawer number 1, the sub drawer number 5, the wave particle duality, the double-sided coin. Okay. So the next one, let's read for 10, 20 seconds. All right. This is drawer number 2. It's very clear. When you read this, do you find any new information? And do you find any new knowledge or new understanding? If yes, put it inside your second drawer. Next. Let's do this for 30 seconds. I'm going to ask Faris. Faris, which drawer is this?
Is the
The third drawer. Yes, good. The Einstein photoelectric drawer. The picture of Einstein, the big nose and the messy hair. Right. And inside the drawer, what do you have? You have the Faris going to the classroom, doing the homework. And you have the story that I mentioned to you just now, the photo energy, and there's a work functions that they need to pay the entrance fee, and then to release the electron from the metal, and that is the maximum kinetic energy, which is the remaining of the energy after you pay the work function. Right? Is this clear? This part? I hope it's clear. Okay, last one on the guide. This part, I think it's easy. Just take 10 seconds to read. Okay, this is also the third drawer, which is the last part here. Right, so just now we started at 3:45. 3:45 is Riyadh time. By the way, we have people from Riyadh, Saudi Arabia, and we have people from Malaysia. And 8:45 is where we started, when we start quantum physics. Before that, we were talking about what is the BrainDrawer method. Right, so this is the formula. You can have a look, quick look. Let's see this and read this in 30 seconds. Now, before we do the short quiz, let's have a look on these keynotes one more time. Right. I'll give you 1 minute. I want you to read from the quantum theory of light until electron microscope. 1 minute. Read it. Then I'm going to ask you one simple question. But now focus on reading first. Let's start now. Done. Okay. The question that I'm going to ask is, do you feel like you understand this more now compared to when you were in step 1? Now we are already in step 5. Can I have some reactions? Do you feel like you understand this more now?
Yes.
Yes. Right. So what's changed? The keynote did not change. I did not change anything. What changed? The only thing changed is you read the notes based on the steps and based on the techniques and based on what is the skill that we are trying to hone for you to improve your skill, right? That is the only thing changed. And how long did we take to do that? Now is depending where you are. We started 3:45 or 8:45. Now is 4:57. It's slightly more than 1 hour. Slightly more than 1 hour. And we haven't finished. Slightly more than 1 hour. And now you are already having a better idea, I think much better idea, compared to 1 hour before. What is quantum physics? Now, let me ask you another question. If I give you 1 hour, imagine that you have no idea about quantum physics like 1 hour ago, and I give you the textbook, SPM Form 5 textbook, and I ask you to read from page 1 until I think the total is about 50 pages. Quantum physics, 1 hour. Do you think that you are going to have this level of understanding?
No.
Right. No, good. Right. For those who did not answer, don't worry. Think about it yourself. If your answer is no, that is good. That means that this BrainDrawer method works for you. Because not every method works for everyone. This is logic. So for Faris, this method works for you. For whoever who answer no, also this method works for you. Now let's continue. Continue on the quiz part. Right, quiz part is the last small part. We have small questions, 10 of them. How do we want to do this? There's a technique. Always there's a technique. So remember, the technique is, okay, what train we are training speed of recall. That is the skill number 2. Okay, everyone remember this. This is a speed of recall skill number 2. What is speed of recall? You still remember? It is to recall the information that you have stored in your knowledge base. For this case, this is the knowledge base. And I want you to know or train your speed of recall of these informations and translate it into the answer. Answer of what? Answer of this quiz. All right. So how do you do this? Now let's continue. You are going to, for each question, you're going to read the questions. Then again, you're going to identify which drawer. Then from here, you pick up the information that you think is relevant to the answer of these questions and form a very simple answer. You do not need to write it in a very beautiful full sentence answer. All right, just form it inside your mind. This answer, the answer is having this type of keywords, right? Black body radiation, black body, and there's talking related to electromagnetic radiations, and then there's temperature. The cold one is low frequency, the hot one is high frequency, etc., etc. Right? I just need you to do that. Once you have done that, now there's a second part here. I will review the answer, and then you do the same thing. You see whether there is any new information, or even better, new understanding. Then you put it back into your drawer. So your drawer will be more and more, right? And I'm sure by now, the information inside your drawer is not only this. Everyone will have different information and even different understanding, right? This is the base. This is the base that you need to have. This is the base that you need to have. Okay? So I hope everyone understand how do we want to do this? What's the drill? So let's do this quickly. I will give you 20 seconds for the first one, 20 seconds to read this. If you've forgotten what is the technique, read the technique below and to perform the things that you need to perform. Okay, for the first one, let me guide you a bit, or let me test you a bit. So what you have read the question, I believe. So let's go to the next step. Identify the drawer. Faris, can you identify the drawer?
It's the first.
Yes, first drawer, the black body.
First.
Right, first drawer, the black body. And then to answer these questions, obviously, you need to put in those informations that is related to black body into this answer. But don't worry about forming it into a very nice sentence. Just keywords will do. Pick it up and form it inside your mind. And that is the answer that you think is correct. Now, next is I'm going to show you the answer. Then the answer that you formed just now, compare it with this answer. Is it the same? If it is not, is there any new information or new understanding now? Because the information that you stored just now it became understanding. You understand something more by reading the answer associated to the questions, right? So let's go to number 2. Oh no. Do you finish reading number 1? I'll give you 10 seconds. Okay, so I'll leave that to you on what are the new information or new understanding that you can put it into your drawer. Okay, let me ask you another question, because I'm also learning using BrainDrawer. I have this feeling. Towards the end of these steps, which is number 4 or number 5 or even number 6 later and number 7, now you are forming more new understanding. Where is this? Okay, this one. For this question, you are forming more new understanding than new information. In the earlier steps, there are informations, new information, and you put it inside your drawer. But as you go towards the later stage, which is step 5 for now, for this case, those information already can form into some level of understanding that you can understand this chapter or this subchapter more. Do you have the same feeling? Yes, good. Only Farish, you are the bright student. Okay, so I hope everyone also have this same feeling. This is the same answer. This is the same question I always ask in every steps, but the distribution of new information now is shifted to new understanding more. Before it was more of new information, but towards the end or towards the later stage or the later step, like now, the new understanding is becoming more and more. All right. I hope you have that also, and I hope you understand what I'm trying to say here. Right. So let's go to question number 2. Let's read it in 10 seconds. I think it's easy to read. And then perform this task. Oh no, go down. Okay, stop. Now I'm going to give you the answer. Perform the same techniques. Another 10 seconds. All right. If you need more time, tell me. If not, I'll move on. Same question number 3. Let's do 15 seconds for this one. Or 10 seconds. It's a short question. Okay, question number 3, answer number 3 here. Let's read it. This one, another 10 seconds. Okay, 4, we are almost there. 10 seconds. This is the double-sided coin. Elise, remember the double-sided coin? Okay, the answer. Another 10, this 20 seconds maybe. All right, number 5. What is photoelectric effect? 10 seconds. Which drawer? Drawer number 2. And what is the answer? The answer is very clear. I don't even need to see the answer. It is related to that story. Remember the story? The torchlight shine the metal and pop out the eyes. Yes, that is the answer. Let's see whether that is the answer. Look at the answer. 10 seconds. So this is read first, please. Sorry. Too excited. Right. So this is exactly the short story that I told you just now, the torchlight with the pop-up eyes. So obviously, when you ask yourself whether there is a new information or new understanding, there's no new understanding. Then move on. Right. So not everything you are having new understanding or new information, especially towards the end, step 5 or step 6. Most of those understandings is already formed. Okay, number 6, 10 seconds. Number 6, another 10 seconds. Number 7, 10 seconds. This is a tricky question. All right. I think I need to give you another 10 seconds for you to form the answer. Okay, let's go to number 7. Let's see the answer. I'll give you 20 seconds to think about it. All right. So let me explain a bit. For those who did not understand fully, let's see the question back. How does increasing light intensity affect photoelectric current and Kmax? How does the light intensity, right? Which drawer is this? First of all, let's ask yourself, which drawer is this? This is a drawer number 2, photoelectric effect, the one with the thunderbolt. And inside drawer number 2, what do you have? You have these informations. I'm sure you have more now, but let's focus on this. You have the intensity, right? It's talking about intensity. So it's talking about the character number 3. Kinetic energy does not depend on intensity. And higher intensity, brighter light, bigger current, right? So that is the answer. The answer is the light intensity will affect the current. Higher intensity, higher current. However, the light intensity does not affect the kinetic energy. All right, because it's mentioned the characteristic over here, kinetic energy not depend on intensity. Let's see the answer. Increased intensity, increased number of photoelectrons emitted. Increased maximum kinetic energy remains unchanged depending on frequency. All right. Okay, we are almost there. Where is it? I know I keep saying that we are almost there. If it is irritating, I'm sorry. Okay, because I wanted to finish this also. Number 8, let's do this. The 20 second. Okay, this 20 seconds is not just for you to read. This 20 seconds is for you to read, identify withdrawer, and recall the keywords that you can form for this answer. All right. If you, yeah, I hope you did that for the past 8 questions. Right. Then let's do this in 10 seconds. All right. If you've forgotten what you need to do, just focus back on these red color techniques. Right. I think by now, already 8 times you're doing this, you already know the drill very, very much. And this drill is similar to the previous 2, 3, 4 steps. Right. So we're almost there. And you also, I think you realize that the drawers is being arranged in sequence. The first few will be the drawer 1, then the middle will be the drawer 2, then the last will be the drawer 3. Very rarely you will skip a different sequence in the drawer. All right. So let's do this. Read the and do the drill. Done. This number 9. Answer number 9 is very simple. Let's do 10 seconds. Good. Let's go to number 10. This is clearly drawer number 3. And the last drawer, last sub drawer. You have the answer here immediately. All right. So do you have the same answer? Let's see. Okay, let's do 10 seconds. All right, we are done. Step 5. Now step 6. I promise you, step 6, step 7, step 8 are the easier one. And how far we have done? Now is 5:15. Is 1.5 hours. It's only 1.5 hours. Right, 1.5 hours is not a very long time, and I hope and I think that you already have a good understanding compared to where you started of quantum physics. Quantum physics is not an easy chapter, right? Okay, let's watch the video, but I'll tell you what's the technique of watching the video. Let me open the video first, see whether it's working.
So what if I told you that the solid...
Okay, do you hear the guy speaking just now? The video?
Yes.
The sound of the video? Yes, okay, good. Now, let me tell you how to watch the video. Okay, it's not just watching. Remember, I told you this flying brain problem? Faris, do you know what's flying brain problem? I did not know when you came in.
Not
Not
no,
sure.
not sure.
Okay, then let me just explain it to you in 1 minute or 2 minutes, right? Flying brain problem means, example, you're reading a book in 1 page, and do you ever experience when you read that page, the top part, you're reading it very well and you understand what the book is telling you, and then towards the end, you are reading it, but you are not understanding the content, and then you flip to the second page. Have you ever felt that experience before?
Yeah.
Yes, I think most of the time. And that is what I call flying brain problem. Why? Because when you are reading, your eyes is doing the job, but your mind is not with you. Your mind is thinking about, have I replied this WhatsApp message? What should I eat for lunch? Nasi lemak or ayam goreng or KFC, right? Or have I planned for this trip that I'm going to Singapore tomorrow, right? So your mind has been wandered all over the world, and by the time your mind came back, your eyes already finished reading the entire page. That is what I call flying brain problem. Now we want to eliminate that problem. How do we eliminate that problem? I want you to intentionally link every message or every slide that you see in this video is a 8-minute video to the drawer. You remember we have 3 drawers and we have sub drawers. So whenever you see any content, and this content is what is this? Which drawer is this related to? Whether it's the first drawer, quantum theory of light, whether it's the black body, whether it's the UV, whether it's the scientist, whether it's the quantum, or whether it's the two coin phase, the wave particles properties, or whether it's the second drawer, whether it's the photoelectric effect, or whether it's the 4 cartoon characters, or whether it's the bigger torchlight, or whether it's the third drawer, Einstein photoelectric theory, right? Or whether it's that formula, the Faris going to the classroom doing his homework, right? Or whether it's the solar panel, right? So I want you to do this commitment, right? Do this commitment, 8 minutes, only 8 minutes. 8 minutes is not a very long time. Only 8 minutes. I want you to commit. When you watch the video, I want you to link it with the drawers. Link it with the drawers just now, as much as possible, to reduce this flying brain problem. Then, by the end of this 8 minutes, you tell me whether you successfully reduce the flying brain problem. Let's start now.
Predictable world you see all around you is, well, it's basically just an illusion. Today we're diving headfirst into quantum physics. It's the story of how science found out that at the very smallest scales, reality starts breaking all the rules we thought we knew. And it all kicks off with a question that sounds pretty simple, right? But the answer would end up tearing the entire world of physics in two. For centuries, people thought the debate was settled, but it turns out really wrestling with the true nature of light would completely shatter our view of the universe. Okay, so let's set the scene. Picture this. It's the year 1900. And physics, well, it feels kind of complete. We've got Newton's laws running the show for motion, Maxwell's equations of electromagnetism all figured out. It really seemed like we had the universe's instruction manual just about finished. And a huge piece of this perfect puzzle was light. Thanks to guys like Thomas Young and his famous double-slit experiment way back in 1801, the science was settled. Light was a wave, period. It flowed, it rippled, it spread out. And energy was the same way. Smooth, continuous, not chunky. It all just made perfect logical sense, or so everyone thought.
But see, that's the thing about science, right? You have to keep testing your ideas. And as our experiments got more and more precise, we started seeing things that the old rules just couldn't explain. That beautiful, perfect picture of the universe was starting to show some pretty serious cracks.
The first big crack came from studying something with a kind of weird name, a black body. Now, don't let the name fool you, it's not always black. A black body is just a theoretical, perfect object that absorbs and emits radiation.
Let me stop here for a while. This is obviously drawer number 1 and the sub-drawer number 1, the small drawer number 1, black body, right? So I want you to do this association. This one relevant to which body? Which drawer? Let's do that for the remaining 6 minutes.
A better way to think about it is the glowing red heating element on a stove, or even a star. As they get hotter, they glow, and the light they give off is based purely on their temperature.
And this is exactly where the old rules went completely off the rails. According to classical physics, as a black body gets hotter and hotter, it should spit out more and more high-frequency light, like ultraviolet, basically shooting off towards infinity. But that's not what happened in the real world at all. Experiments showed the radiation hit a peak, and then weirdly, it dropped off. The theory was so wrong, so spectacularly wrong, they nicknamed it the ultraviolet catastrophe. The rulebook was officially broken.
So the ultraviolet catastrophe was a total dead end. It was a brick wall for classical physics. To get past it, the solution required a completely new, and frankly, a very, very weird way of thinking about the most basic thing in the universe, energy itself.
So in 1900, this physicist named Max Planck came up with a solution that he himself called an act of desperation. He just threw out this idea, what if energy wasn't smooth and continuous? What if it could only exist in tiny, separate little packets? He called them quanta. It was a total guess, really, just a mathematical trick to make the problem go away. But when he plugged it in, the ultraviolet catastrophe vanished. The math worked perfectly. He had accidentally stumbled upon a brand new fundamental rule of the universe. And just look how fast the dominoes...
Oh, sorry, my mic was off just now. I was saying that just now that part was drawer number 1 and under the sub-drawer of quantum energy. Let's continue. This one is obviously the scientist part, right? Now I think you realize that the drawers are all jumbled up. It's not as sequential as what we did from the previous few steps.
Fell after that. Planck's act of desperation in 1900 wasn't the end of the story. It was the starting gun. Only 5 years later, a young patent clerk named Albert Einstein takes this quanta idea and just runs with it. Then, less than 20 years after that, Louis de Broglie flips the whole thing on its head. We're talking about a complete revolution in how we see reality, all within a single generation.
You see, Einstein saw Planck's quanta and thought, hey, maybe this isn't just a math.
Hello, yes. So now this is drawer number 2, obviously, right? Let's continue.
Math trick. Maybe it's a clue to another big mystery, the photoelectric effect. Now, the observation here is simple. You shine a light on a piece of metal, and sometimes it knocks electrons loose. Sounds pretty straightforward, doesn't it? But, as you can probably guess, it made absolutely zero sense under the old rules.
The experiment itself couldn't be simpler. You've got light hitting a piece of metal, electrons fly off, and those moving electrons create a current you can measure. Easy. But the results from this incredibly simple experiment were about to cause a massive headache for the whole light is a wave idea.
Here we go again. The classical wave theory just completely fell apart. It predicted that any light, as long as it was bright enough, would eventually build up enough energy to knock an electron out. But the experiments showed something totally different. Below a certain threshold frequency, nothing happened. You could shine the brightest light in the world on it, and not a single electron would budge. And even weirder, when it did work, the electrons flew off instantly. No delay. It was like they were getting hit by a tiny bullet, not being washed away by a slowly building wave.
And this is where Einstein had his incredible flash of genius. He took Planck's quanta and applied it to light. He said, forget the continuous wave. Light is actually a stream of these tiny energy packets. He called them photons. And just like that, everything clicked. A single photon hits a single electron. If that one photon has enough energy, which means it has a high enough frequency, bam, it kicks the electron out instantly. If it doesn't, nothing happens. It's not about the overall brightness, it's about the punch packed by each individual particle of light. So, wait a second. Is light a wave, which explains stuff like diffraction, or is it a particle, which explains the photoelectric effect?
All right, which drawer they are going to explain? At least remember the coin, the double-sided coin, the wave and particle properties. That is the drawer. That is the sub-drawer that they are going to tell you. So any new information or new understanding that you find, pick it up and put it inside that drawer of yours.
Which one is it? And the answer, incredibly, is yes, it's both. And right here, this is the weird beating heart of quantum mechanics. I mean, on the one hand, the evidence for light being a wave is just undeniable. You shine it through a tiny little slit and it spreads out, creating these interference patterns of light and dark bands. That is textbook 101 classic wave behavior. Case closed, right? Oh, not so fast. Because this is where reality gets truly, deeply weird. In 1924, Louis de Broglie asked this amazing question. If waves can act like particles, could particles act like waves? So they tested it. They fired electrons, which are definitely tiny little pellets of matter, at a crystal. And what they saw was impossible. They got a diffraction pattern. The electrons were behaving like waves. Just think about that for a second. A single solid object was somehow interacting with itself as if it were smeared out all over space. And that leads us to the absolute core concept of quantum mechanics. Wave-particle duality. It isn't an either-or situation. It is both at the same time. Light, electrons, you, me, everything at this fundamental level exists in this bizarre hybrid state. It only chooses to look like a wave or a particle when we force its hand by measuring it. This is the new rulebook. It's strange, it's counterintuitive, but it's how the universe actually works. Now, I know what you might be thinking. This all sounds incredibly abstract, maybe a bit of a brain melter. But these weird rules aren't just a curiosity for physicists in a lab. They are, and this is not an exaggeration, the foundation of our entire modern world. So why should you care? Well, the image sensor in your phone's camera, that's the photoelectric effect in action. Solar cells converting sunlight into electricity, that's all about photons. The electron microscopes that let us see viruses and design new medicines, they rely on the wave nature of electrons. And today, we are pushing this weirdness to its limits, building things like quantum computers and unhackable encryption systems. These strange quantum rules are literally the blueprint for our future. And that leaves us with one final, kind of unsettling thought. The solid, predictable world that our senses show us is really just a high-level summary. Underneath it all, the universe is this shimmering dance of probabilities and possibilities, governed by rules that defy all our everyday intuition. The quantum world isn't a theory about something out there, it's the fundamental reality that we are all made of. And the real question is, what other secrets is it still waiting to reveal? Thanks for joining us.
All right. So do you feel that your flying brain problem being reduced by a little or a lot? Do you still have this flying brain problem?
No.
Who is this? Jovin?
Ah.
Jovin, you just joined us. Your no is a real no, or your no is just because
Real,
you want to answer
real.
no?
Real.
Okay. So Faris, do you feel that your flying brain problem is reduced?
Kinda.
Kind of means it's not very sure. Okay, let's continue on the next step. The next step. So it means your flying brain is still there. Okay, no problem. Next step is podcast. Okay, podcast. I'll open another shorter podcast. Right. This is how I created most of the notes and most of the video and also the podcast. Right. But first, you need to understand the method first. Once you understand the method, then you'll be able to know, or on the next session, if you're interested, I'll be able to teach you how to use this notebook LM to create those notes. But first, let's start with the understanding of the BrainDrawer method. Now, what I'm going to do next is, let me open this one. Okay. What I'm going to do next is, I'm going to play the podcast. It's only 6 minutes. So please, if you can just commit to these 6 minutes, don't look at your phone, don't look at your iPad, don't look at your message. 6 minutes, listen to the podcast. What I'll do, I'll highlight which drawer it is referring to, right? That will help you to reduce your flying brain problem, right? And when you discover new information or new understanding, put it back into your drawers. Okay, let's do that. Let's start now. It's not starting. Let me refresh a bit. Sorry, let me refresh first. Let's hope it will work now.
Welcome to the deep dive. Today we're getting into something truly mind-bending, quantum physics. Ever wonder how understanding the tiniest bits of energy connects to things like quantum computers or super secure encryption?
It's a fascinating link, yeah. And we're going to explore some of the core ideas, the quantum nature of light, this really wild concept called wave-particle duality, and something called the photoelectric effect.
Right. Our mission really is to unpack these fundamental concepts, show why they totally change physics, and how they actually impact the technology you use every day. Let's jump in.
Okay, so first up, the quantum theory of light.
Wait. Do you see me highlighting those points in the keynotes? This is the keynotes. Can I get an answer? Do you see me highlighting, like, for example, wave particle duality?
Yes. Yes.
Okay, so let's continue.
Light. For ages, everyone thought light was just a smooth, continuous wave. Classical physics worked fine for lots of things.
But not everything, right? There were problems.
Exactly, especially with explaining something called black body radiation, basically how hot objects glow. Experiments just didn't match the classical predictions. The theory predicted something impossible, the ultraviolet catastrophe.
Infinite energy. That definitely sounds like a problem.
A big one. It showed classical physics was missing something fundamental. And then Max Planck stepped in around 1900.
What was his idea?
He proposed something radical. Energy isn't smooth and continuous. It comes in these little discrete packets or chunks. He called them quanta. Think of it like money. You have pennies, dimes, dollars, but nothing in between, specific amounts.
Okay, so energy has specific levels, like steps on a staircase, not a ramp. Got it.
And Einstein built on that.
He did, yeah. In 1905, Einstein took Planck's quanta idea and applied it specifically to light. He suggested these light energy packets are actual particles called photons.
But light isn't just a wave, it's also these tiny energy bundles.
Precisely. And crucially, he linked a photon's energy directly to its frequency. The famous equation E equals hf. E is energy, F is frequency, and h is just a constant number, Planck's constant.
What does that mean practically? E equals HF.
It means higher frequency light, like say blue or ultraviolet light, has more energy packed into each photon compared to lower frequency light, like red or radio waves. Ah, okay. So that's why a blue star is hotter than a red one. Its photons have more energy.
Exactly. Each photon delivers a bigger energy punch. It's all about discrete energy packets.
Which leads us nicely into the next really weird idea, wave-particle duality. We just said light is particles, photons. But we also know from experiments, things like diffraction and interference, that light absolutely behaves like a wave. How can it be both?
That's the million-dollar question, isn't it? It behaves like a wave sometimes and like a particle other times. And then this physicist, Louis de Broglie, in 1924, he flipped the question.
How so?
He wondered, well, if waves like light can act like particles, maybe particles like electrons, tiny bits of matter, maybe they can act like waves.
Whoa, so electrons act that? Sounds even stranger. Was he right?
He was. It took a few years. But experiments in 1927 actually showed electrons defacing, making patterns just like light waves do. It was revolutionary.
And this isn't just a weird theoretical thing?
Not at all. This wave nature of electrons is exactly what makes electron microscopes possible. Because electron waves can be incredibly short, they let us see things in vastly more detail than we ever could with light. Think like seeing the structure of a virus.
Incredible. Okay, so light is a wave and a particle. Electrons are particles and waves. This quantum stuff is definitely weird. Let's move to the photoelectric effect. What's that about?
Right, so imagine shining light onto a piece of metal. Sometimes electrons get knocked right out of the metal surface. These are called photoelectrons. That's the basic effect.
Okay, seems simple enough, but classical physics couldn't explain it properly.
Nope. It failed spectacularly. There were three main confusing things in the experiments. First, electrons only came out if the light's frequency was above a certain minimum level, the threshold frequency, specific to each metal.
So below that frequency, nothing happens,
Yeah.
even if the light is really bright.
Exactly. No electrons, no matter how long you shine the light or how intense it is. Classical wave theory just couldn't explain that threshold.
Okay, weird point number one. What else?
Second, if the frequency was high enough, the electrons popped out instantly, no delay. Even if the light was super dim, classical waves should have needed time to build up enough energy.
Instant emission, also strange. And the third thing.
The energy of the electrons coming out of their kinetic energy depended only on the light's frequency, not how bright the light was. Brighter light knocked out more electrons, sure, but each electron wasn't more energetic.
Right, so frequency determines the energy, intensity determines the number. This sounds like those photons might be involved again.
You got it. Einstein's photon idea explained it perfectly. He came up with the equation HF equals W plus Kmax.
Okay, break that down for us.
So HF is the energy of one incoming photon, which we already know depends on frequency. That photon hits the metal. Part of its energy, W, is used up just to free the electron. That's the work function, the minimum energy needed to escape. It's like an exit fee.
The work function. That explains the threshold frequency, right?
Yeah.
If HF isn't bigger than W, the electron can't pay the fee.
Precisely. And if HF is bigger than W, the leftover energy becomes the electron's kinetic energy, Kmax, making it move. Since each photon interaction is one-on-one with an electron, it's instant. And more photons from brighter light just mean more electrons get hit, not that each electron gets more energy.
That actually makes perfect sense with the photon model. Amazing. And this effect, it's used in real technology.
Absolutely. It's fundamental to solar cells, converting sunlight directly into electricity. You see them everywhere, powering street lamps, satellites like the ISS. It's also used in light detectors, in things like automatic doors, and crucially in the image sensors inside digital cameras and smartphones. They capture light, photon by photon, to create the pictures you see.
Wow. So from Planck's quantum idea to photons to wave-particle duality and the photoelectric effect, these concepts were totally radical, completely changed physics.
They really did. They formed the bedrock of quantum mechanics, which underpins so much modern science and technology.
It really makes you think. We've seen how these fundamental ideas about energy and matter, once revolutionary, are now part of our everyday tech. So here's a thought to leave you with. If our understanding of reality changed so dramatically at the quantum level, what other seemingly obvious truths about our world might just be waiting for a new perspective, a new theory, to reveal something completely unexpected hiding beneath the surface?
All right. Did your flying brain problem reduce by focusing on the highlight that I've been showing you just now? I hope it does. I hope it does. And it's not only that, I think the new information or new understanding that you are able to form, you are able to put it more information or more understanding into your drawers, into your own drawers. Like I say, everyone's drawers now is totally different. I helped to build the first drawer, the first phase, and you are the one who is building your own drawer to make it more dense, more crowded with items, with images, with stories. Right, we are going towards the end of the steps. The next step is the last step, which is create story. Right, this story is the story that I built and I created by myself. You can create your own story that is relevant to you. Remember the game, the memory game that I played with you a while ago, maybe before we start this quantum physics. Emotion plus information equivalent to long-term memory. So we are creating a story that will create some level of emotions to help you to form a long-term memory. Right? Like I say, you can create your own story. Let me tell you my story. Drawer number 1 is divided into drawer number 1, number 2, and number 3. Drawer number 1, and based on the keywords that I've got from the keynotes, and now I understand these keynotes more and more, I created this story. The story is the black body. There's a black body that absorbs all the magnetic radiations, and when the temperature is high, it turns into a sun. So the black body turns into the sun. It's an illogical story, so don't worry about the logical part of it. As long as it is able to help you to understand the flow and understand the keywords, right? So let me continue. And that sun is, before that, and when the temperature went up, it became the sun, the frequency went up, the wavelength went down. And that sun is shining intensely into the grass that is beneath it. This one looks like a grass, and also I intentionally draw it like a sine wave or cosine wave to show frequency, right? To show frequency. So when it's when the sunlight shine intensely, it doesn't affect the grass. That means it doesn't affect the frequency. So it's actually explaining this. It doesn't give you unlimited energy at a higher frequency, right? Then the second part of the story for quantum theory of light is, I call this guy Akwan. Malaysian Chinese, there are some people, their surname is Kwan. So I call him Akwan. Kwan represents quantum energy. So quantum energy, or Akwan, now is in KL, Kuala Lumpur, and he traveled to JB, but he did not travel from KL to Seremban to Malacca, then to JB. He flipped, or he immediately appeared in JB in 1 second. So this is to explain the discrete energy, and it's not continuous. It's the quantum energy, the photon of light, right? And Akwan in KL, he's waving to Akwan in JB. And within 1 second, Akwan in JB holding a ball, which is representing a particle, and looking at Akwan in KL. So what this wave and particle represents the wave-particle duality. Wave-particle duality that is talking about the light as a bit, the two properties, wave properties and particle properties, right? And there is this Broglie hypothesis. So that is the drawer number 1. Drawer number 2, photoelectric effect. There are two stories over here. The first story is the story that I've already told you quite a few times. A torchlight that is shining on this metal, and the metal's eye pops out. That is representing the definition of photoelectric effect. And then regarding the characteristics is let's say Faris joining a high jump competition, and he jumps so high that he needs to jump above the threshold of this wall, right? And the threshold of this wall is representing the threshold frequency, and this is on this part. And then when he jumps, means that his frequency is higher than the threshold frequency, and when he jumps, that means he has a higher kinetic energy because his motion is higher. So this is to explain the point number two. Point number one: higher frequency of photon light, higher kinetic energy. Then when he jumps over, Faris jumps over, what happened? He instantly eat instant noodle, Maggie mee. Maggie mee we call instant noodle. Why I want to call instant noodle, not Maggie mee? Because I want to represent instantaneous emission. So the instantaneous and the instant sounds similar, right? So once you eat this instant noodle, it's not spicy. Not spicy means there's no intensity. And it's not intense. The kinetic energy does not depend on intensity. So those are the keywords that I'm trying to link for those drawers. Then drawer number 3, Einstein photoelectric theories. You have this a gun that is firing a photon on a metal. And this metal moved from point 1 to point 2. And what happened? When the point 1 moved to point 2, there is a kinetic energy created. That means there is a motion created. And there's a work done. There's a work done. Of course, everything you have to do some work to move one point to another point. So what does it tell you? It tells you that there is a photon energy, which is this HF. HF is the photon energy, and there is a work done. There's the work function, equivalent to work function, and plus the K max, which is the kinetic energy. So this is the story of the step 8. Now, imagine. I need you to focus with me now. Imagine that you are going for exam tomorrow, SPM, Form 5. I think Faris, you are Form 5, right?
Yeah. Yeah, I'm Form 5.
So in 2 months' time, you're gonna have this big day for you, right? Imagine Xian is also Form 5. I think TVI is maybe Form 5. The rest are not Form 5. The rest are younger. Venice maybe. Venice has been very quiet. Now, imagine that this picture, you are able to draw this picture in less than 1 minute. And that means you are already able to understand quantum physics by just looking into this picture. Because this picture itself is helping you to remember the points and the keywords and the understanding and the information inside these 3 drawers and inside their respective sub-drawers. I'm sure by now, Faris, your drawers, the things that is stored in your drawers, is different from mine. It's different from Xian. It's different from Tevia, right? So when you are in the exam hall, you cannot bring these notes in, but you can bring this, not bring this, as in you can draw this. For the first 1 minute, you draw this out. How many chapters do you have in physics Form 5? You have 7 chapters. You have force and motions, you have pressure, you have electric, you have electromagnetism, you have electricity, you have nuclear physics, you have quantum physics. You just need to draw 7 drawings, right? I'm sure you need to practice this like 20, 50 times. Once you do that, you already know this by heart. Maybe you don't even need to draw it. You just close your eyes, you'll be able to have this picture on your mind now. And from there, you'll be able to effectively bring the entire book into the exam. And the best part is, if you are bringing the book, you still need to flip. This one, you don't even need to flip. You know exactly what is black body radiation now. You know wave-particle duality. You know quantum energy. And you know what is photoelectric effect. And you know what are the 4 characteristics. And you know how to explain Einstein photoelectric theory. by putting out this formula and explain it in more details. The threshold frequency, the kinetic maximum, the photon transfer to the electrons. Right. Now, I think by now, everyone already have a better understanding of what is quantum physics. Am I right? I hope so. If not, then I'm not doing a good job. Can I get some
Yes,
reply?
sir, yeah. I understand.
Right? Right, you understand? Now let's put a small test. Very small. It will take not more than 10 minutes. Not more than 10 minutes. Okay. What I'll do, I'll open my ChatGPT. I will upload a file, and that file name is physics chapter 7. Okay, I'll open the chapter 7 and tell you, and let you see what exactly is this chapter 7. This is exactly the textbook of the SPM student, right? So you have about 29 pages. Let me just scroll through quickly. Oh no, let me just scroll through quickly by having showing you some sub-drawers and drawers. So you see, first drawer, quantum theory of light. Then you can imagine they are talking about black body. Then you can imagine they are talking about the next one. The next item is the UV, right? The UV catastrophe, ultraviolet catastrophe. Then the next one is the scientist. Then the next one is the quantum energy. You have the line spectrum. Next one is wave particle duality. Am I right? Let me just open this quickly next to it. Right. Just now is wave particle duality. Next one, what is going to happen? They're going to talk about photoelectric effect. Right. This is not done yet. Photoelectric effect. What is the next one? Is going to talk about? It's going to talk about the definition. Then it's going to talk about the 4 characteristics. Then it's going to talk about the third drawer. It's not refreshed. Okay, it's not refreshed for some reason. My internet is slow, maybe. This is going to talk about the third drawer, and then the third drawer is going to talk about yes, it's out. Yes, right. The third drawer is Einstein photoelectric theory. Then it's going to talk about the formula. It's going to talk about that work function. It's going to talk about the kinetic maximum energy. Then it's going to talk about the work function is here, right? More details. Then it's going to talk about the applications, right? So you can see it is very much aligned on the sequence. Right. Now, when I ask you what is quantum physics, you already know how to explain. Start with first drawer, second, then for continue with second drawer, then continue with third drawer. Right. That is how you are able to remember this. Right. And to help you to remember this, when you able to form your own story, or you can use my story, and then you keep memorizing this story to be able to draw this out. That is where you will be able to bring that exam, the book into the exam, because you cannot bring this in. You will not be able to bring this in, and you will not be able to memorize this easier than this. Am I right? That's why I say human brain's nature is not easy for you to work with text, but our brain is easy to work with space, work with pictures, work with emotions. So I'm translating this, where is it? Sorry. Into this. All right. Next, let's go to the ChatGPT. Okay. Now, provide me 10 MCQ. MCQ is multiple choice question without answer. So this is to prove that I did not write the question out by myself in order for you to get high score. This is a randomly generated question by AI. So let's answer this 10 questions and see how many points that we get. Right. Number 1, I want somebody to read out loud, then tell me which drawer. Then everyone can contribute on which answer you want us to put it here. let's start with Xian. Xian, can you read out this and then tell me which drawer?
A black body is defined as. This one is.
Then tell me which
first
drawer.
First drawer light bulb.
Yes.
The black body.
Excellent. Okay, now imagine that now you're in the exam hall. In the exam hall, you have objective, you have structure, you have essay. Now we are answering the objective. And imagine that you already use this 1 minute to draw out this picture and it's next to you. So you can use this as a reference. So what is the answer? Can anyone tell me what's the answer? Where is the answer? Answer is here, somewhere here. Who can tell me the answer? Absorb.
B,
Is it absorb? Somebody said absorb. So what is it? Is it A, B, or C, or D?
B.
Okay, B.
B.
B also. Okay, good. Number two, Faris. Read out and tell me which drawer.
According to Max Planck, the energy of a photon is still the first drawer.
Yes, good.
The scientist.
Okay, scientist drawer. Okay. Answer. Anyone can give me the answer? Or Faris, if you can give me the answer.
True.
Which one? A, B, C, D? Anyone? Not only Faris. Anyone who is who knows the answer, you can tell me.
I think it's C.
C. Okay.
I'm not mistaken.
I don't know the answer, by the way. Okay. Like I say, I'm learning together with you. Right. Let's go. If anyone thinks that it's not C, then you can raise your arm and tell me. Okay. Question 3. Who else? Elise, you want to read? Just read. Read is easy.
Sorry?
Number 3, can you read the question and tell me which drawer?
Which experiment confirmed the wave nature of light? Was that number 2?
Yeah, this is difficult because this is not inside our notes. All right, anyone have the answer?
It's B.
Yeah, sure. Okay, I don't know. I don't know the answer. Okay, because this is not in our notes. Like I say, the notes is not near to 100%, but it's not 100%. So this is one of the questions that is showing that the note is not 100%. Okay, next. Number 4. Sven, can you read the answer? I'll read the question. Number 4, just read the question.
Release the visual process that propose that
Okay. Which drawer?
1.
No, not the answer. Which drawer?
1.
Drawer number 1, yes. Okay, anyone want to answer? Or Sven, if you want to answer also, it's fine. Anyone want to answer?
It's B.
B. Good. Number 5. Let's do Faris. Let's do Faris, right?
Number 5.
Let's read the questions. Let's read the question.
In the photoelectric effect, photoelectrons are emitted only if this is the third drawer. No, the second drawer.
The second drawer, yes. So the second drawer, you have this story. Right. Can you find the answer from this story? Okay, what is the answer?
The B.
B.
Above threshold. Because high jump competition.
Yeah, that's why I put you there. I put you there in the competition. Okay. Number 6. Since Xian, you are going for exam, so let's focus on you. Let's tell me the questions. Read the questions. Sorry.
Which of the following does not affect the maximum kinetic energy of photoelectrons?
Which drawer? Which drawer?
Kinetic energy, second drawer.
Yes. It's actually the characteristics. Okay. So what is the answer? Does anyone know? Is it here or is it here?
D, Planck's constant.
Looks like I think it's a right answer. I don't know. I'm not the teacher here. Right, number 7. Let's focus on between Faris and Xian because both of you are taking exam. Okay, then Faris, now read the question and tell me the drawer.
Number 7, right?
Yes.
The work function of a metal is defined as
Which
this
drawer? Which drawer?
is drawer 2.
What function? What function
Because
is
homework.
what?
Oh, 3. Homework.
Yes, homework. Exactly. Right. Okay, now which answer? Xian
It's C.
and Faris? C?
I think it's
Number
C. What about CN?
Xian, you think it's A? You think it's C?
C.
You also think it's C? Okay, then should be C, I think. Okay, number 8. Now Xian turn. Read the question and tell me which drawer.
Einstein's photoelectric equation is
Which drawer?
drawer 3.
Yes. Okay, drawer 3. Then look at this nice picture that you've drawn just now. Any answer?
B.
B. Okay, 9. Okay, Faris, your turn. SPM student.
Which application of the photoelectric effect is used in automatic doors? This is the third drawer.
Yes. Okay.
Application of photoelectric. Solar. A.
Xian,
B
what do you think?
can also be.
Xian, what do you think? A, B, C, D, E, F? B?
B.
Okay, 10. Xian, your turn. Last one.
Increasing the intensity of incident light with frequency above threshold will. This one is.
Which drawer? Intensity.
Drawer.
Intensity is related to spicy.
2.
Yes, drawer 2 is related to spicy. You see this way I circle. Yes, good. So drawer 2. So have a snapshot on this picture and then see what is the answer.
C. Number.
Correct? Okay.
C.
Tara, tell me the score. Excited? Are you ready, everyone? Wow. Are you expecting that? Are you expecting, or you're expecting 100 over 10 over 10? Xian, Faris.
Huh?
Was it a good?
I think it's good.
Was it a good score?
Yes.
In 2 hours. In 2 hours.
In 2 hours.
From almost I don't know what is your understanding about quantum physics. Just now I talked to Xian before we started. She says she's not so confident about quantum physics. To 9 out of 10. Faris.
Yeah.
Were you well equipped with this knowledge before you come in?
No.
No. Okay. And one more thing is, I think one thing is very important is is also relevant to everyone here. When Xian and Faris answer these questions, you are not guessing. The only thing you guess is maybe number 3, because number 3 is not in the notes at all, right? Do you feel that the guess sentiment or the question that you guess is much lower than when you are practicing in your past year questions, and you are very confident on the answers when you put in the answers, right? So that shows that the understanding of this chapter is very strong. And those questions that was given, it's not super hard. I have to agree, but it's not super easy, right? It's not super easy. If I've given this 10 questions to Xian 3 hours ago, and Faris 3 hours ago, I am very sure that you are not going to get this score, and also you don't feel very confident when you answer most of the questions, right? So that's it for today. Congratulations. There's one more thing. Last thing. Okay. I'm sure some of you is going to ask. Now, this is especially for Xian and Faris. This is chapter 7. What happened to chapter 6, 5, 4, 3, 2, 1? What happened to Tingkatan Form 4, 1, 2, 3, 4, 5, 6? Right. I've done some work on the other chapters, but it's a video on Udemy. It's free of charge. You can get this link, and then you can get this video. What I want is if you finish the video, you tell me your feedback, whether this video is something that is going to help you, or this video is not helping you because it's too boring, or any point of improvement, right? So how do we communicate? You can add me in your WhatsApp group, in your WhatsApp. You can send me one message. Then I can send you this link. Then you get the video for these 3 chapters. You can even get this chapter as well. So write down my number and send me a WhatsApp message. Then I'll send you the link. Right. Whoever who wants this video, you can send me one WhatsApp message. All right. Is that clear?
All right.
Congratulations, and
Yeah.
I hope you learned something new today, and I hope this is beneficial for you. And yes, see you soon. Thank you very much.
Thank
Sir.
you. Bye.
Thank you.
Thank you.
Sir,
Thank you,
Yes,
sir.
yes,
I have a question.
please.
For the concept of flying brain. So basically, is it just for us to not get distracted?
The concept of what? Sorry? The flying brain. Yes.
Yeah, the flying.
So when you have an anchoring point, thank you, Sren. You have an anchoring point, then you will not have this flying brain. Your mind will not fly all over. Why your brain keeps flying? Because your brain is distracted. It's always whether I have replied this WhatsApp message. Then suddenly your phone, you have some notifications coming out. Then you'll be thinking about what I want to eat for lunch, and whether I should do what in the weekend with my boyfriend or girlfriends. Right. So rather than having your mind distracted, the BrainDrawer is helping you to refocus and be busy with listening to the content by focusing on the drawer respectively.
Oh.
Right, you see?
So
And
actually, the drawer and the flying brain concepts are related.
The drawer can help you to reduce your flying brain problem. Imagine this drawer is not there. Today, how do you read? You read by reading books. There's no drawers. There's no anchoring point. There's nothing to focus. Right? You just read. Chances of your flying brain problem will occur is so high because there's no point for you. There's nothing for you to focus. You cannot focus. But with this, you know that when he's talking about the quantum energy, oh yes, I have to focus here. And if he's talking about quantum energy and he's talking about something more than this, this is a new information or new understanding that I have to put it inside my drawer. And if he's talking about the photoelectric effect, this is the point. Is he talking about new things? No. Okay, fine. Then next. Next one is talking about the formula. Is he talking about the new thing? No. Fine. Next. So your mind is busy focusing on what is matter. Your mind is not distracted. And only BrainDrawer is having this anchoring point because that is how the BrainDrawer is designed. Every chapter will design a drawer for you.
All right.
Is that clear?
Yes, clear.
Okay. So if you
Okay.
if you want, you can drop me a message. I'm not from Malaysia. I'm Malaysian, but I'm not in Malaysia. This is my number. It's a Saudi number. Then I'll send you this link. For Xian, you can send it to me directly, or I can send it to your father. It's fine. If you want, right? But I need one thing. Once you watch it, you tell me whether there's any feedback and any points to improve and things, because I'm also doing this the first time. Okay. Thank you very much, Xian. Thank you for your time. Thank you, Faris. And I hope
Thank
you
you,
learned
sir.
new things today.
All right. Thank you, sir.
Bye-bye. Good night.
Good night.
Good night.
Good night.